Hey guys, welcome back to the channel. Today we'll be doing episode number 6 or 5 of creating our custom ray tracer in C++ and Unreal Engine. If my voice is a little bit sore, I just woke up and I got into making a video right away, so excuse me for that. In the last episode, we left off with creating our basic implementation of anti-aliasing. Now, I forgot to make a disclaimer in the previous video, and that is our implementation of anti-aliasing is actually quite primitive, so to speak. There are better implementations of anti-aliasing like FXAA and MSA and stuff like that. You might have seen that in video games. So since it is primitive, we actually have some downsides. If you see closer on the images, if you look closer at the renders that we put out last episode, you'll actually see some distortions in the horizon and the edges. And that's the side effect of using random points and sampling random pixels or random points around a target pixel, right? So you will have some upside down pixels or pixels out of their position, so to speak. And I don't really care about that because that's not the focus of this series. The focus is actually make a ray tracer, and anti-aliasing is actually a big part of ray tracing to get that smooth effects. As you saw in the previous video, it was like day and night changes, but I think for this level of information or this level of ray tracer, it's quite enough, right? So with that said, today we'll be implementing metallic objects and adding colors to our materials. As of now, we only have this. We have a diffuse monkey we imported last episode using custom meshes and complex collisions, and we have a white background that is reflecting, or that is the source of all the colors in the scene. So we're actually just sampling 0.5 multiplied by the sky color essentially, because ultimately every color is just going to come from the sky, because every other color is just return statement, having the same return statement without any attenuation. So no absorption right now. So we'll actually first implement our metallic function or reflect function and then add some colors to it. Let's first go to our Visual Studio, our ray tracing, and let's come back to our hittable object or hittable CPP, and let's define certain conditions, right? So last time we actually have just one statement or condition. We're just checking if our material or our hittable object is having a diffuse material. Now let's add a second condition. Let's actually check else if b metal, right? And then we can just return normal for now. I don't want Visual Studio to scream at me for not returning a value. Let's actually come to our ray utilities, our header file, and then define our reflect function. So just below our random unit vector declaration, we can come down and put in f vector reflect. Now, if you want to learn more about reflections and surface reflections, total internal reflections and stuff like that, which we'll be doing in the next episode when we come to refractions, you can actually go to Wikipedia or some physics site and learn more about it, because it's quite mathematical and quite abstract. So I won't be covering the mathematical side of this equation in this video. I'll just put down the equation and just see the results on the screen, right? So yeah, we'll be taking in sorry, my voice is quite sore today. I don't know why. Again, maybe it's just because I woke up. I just woke up. So we'll be taking in two parameters, so f vector, and one will be v and f vector and n. So quite abstract naming convention here. Following Peter Shirley's book, v is actually the ray direction, so the incoming ray. So if this is a metallic surface, This is the incoming ray, this will be the V, and then we'll reflect it outside, right? And the normal is pretty much the normal of the surface, which you'll get from the line trace dot hit result dot get normal, right? And we'll create a definition, and we'll come and return. I think it's pretty simple. We can just do it in one line. It's can't quite remember, but it's v minus 2 multiplied by v dot the dot product of v and n multiplied by n. So this is going to be our reflection direction, right? So let's actually build this to check if we have any errors. Yeah, and the build is successful. Let's come back to our hittable CPP and then implement the or call the reflect function. So let's come and say reflect or ray utilities dot reflect, right? So yeah, obviously dot reflect, and we should have a ray direction, which we already have, and a normal, right? So that's just to be safe. Let's actually come up here just to be safe. Let's actually normalize our ray direction. I'm sure we are actually normalizing it in the ray tracer call, but let's do it again just to be sure. If you have repetition, we'll come and rectify it later on. Get safe normal, because this actually makes quite a bit of difference in ray tracing. If you don't have safe normal or normalized vector, you can see some really weird results, right? So that once that's done, we can actually save it all up and check our result of a metallic object. So that's done. Why is Unreal minimized all the time? I have no idea. And let's come to our blueprints and get our hittable ball, and let the ball be metallic and a monkey can be diffuse. So let's make the ball metallic and the monkey as diffuse. Let's render this out and check. I think, yeah, we're not piloting the object. So let's try this. We should actually see the monkey reflected in the metal ball as well. So yeah, we can see something going on. We can actually see the monkey here. I don't know what's going on here. So let's actually bring this up. I don't know if it had something to do with the color values, or it's just the thing has very low poly count. The ball, I mean, right? We won't be able to tell unless we have a ball of a high resolution, which I do have in handy from Blender. I actually exported a high resolution ball mesh, which I'll get now. Blueprints content. Yeah. So we have a smooth blow. So we have a smooth ball. Let's come to blueprints and hittable ball, and actually get the sphere replaced with our smooth ball. Okay, it's going to be big, but I think it's fair for now. Yeah, it is big, but that's fine, right? So let's actually render this and check. We should have a higher poly count here, so we can see better reflections. And yeah, okay, this is a problem we addressed in the last episode. We need to come to our sphere, static mesh, and come all the way down to our collision presets. Use complex as simple, right? So now we should have a proper metallic reflection. Yeah, so we can see the monkey in the ball, so metallic reflections. So I'll actually bring that quite out there and render this for one more time. Yeah, so we can see the monkey, but obviously the resolution is very low and the samples are low. So now let's actually add colors to our scene, because right now it's quite boring. Okay, so to add colors, We need to do two things first. First thing is we need to rectify our background color. As you can see in the return statement of our ray color loop or recursive call, we actually have a final return statement, which if none of the above statements are true, will just return a white color. This statement will only be true when we don't hit anything. That's the first condition. And or if the ray depth is less than or equal to 0, which effectively means the ray is pointing towards the sky or infinitely outwards to some point. And that point is usually the sky, right? When you think about it. So the sky value is actually the return statement here. So we need to actually define our sky colors here, right? Now I'm not actually going to define a solid color. We'll actually define a lerp gradient. And in order to do that, we need to come to our ray tracer header file and define a couple of U properties. Like actually defined it already here from the test I was running. So U property F linear color background color 1 and F linear color background color 2. So now what this effectively does is when you come to Unreal Engine, you can see in our ray trace manager we have two color value options. I've set it to light blue and dark blue, and this is going to be that gradient shifting from lower to upper, right? And that's going to be our sky. Let's come back to YouTube ray tracing, CPP, and first thing we need to access those F linear color as a vector. So let's actually define background color vector, or maybe I can just say background color 1 because we have already defined a different name. So we can say background bg1 basically, and r bg1 dot g and bg1 dot b. Okay, we'll do the same thing for background color 2, convert it to a vector. So we have two color vectors, right? So next thing we want to do is actually access a value. So it could be any variable name, but we are calling it a. Auto a is equal to, it's 1 minus, not 1 minus, it's actually the ray direction. So the in ray direction, the z component, so the vertical vector or the vertical axis. So it's going to be ray direction dot get safe normal. Will actually normalize it. So we're doing a lot of normalization here for the same value. So I think we are repeating the normalization over and over again. We'll have to rectify that soon. Dot z. So this is going to be the up vector, right? Plus 1, and this can actually be 0.5. So that's our a value. Now we can just come down and say color vector or f vector background, or yeah, background color vector. I'll just put vec and we'll name it, or the linear interpolation, right? So it's, I think it's 1 minus a multiplied by background color 1. So background color 1 plus a into background color 2. Put this in separate brackets, and we can just return our background color vector bg color vector. Fine. So now we should have a sky color let's actually quickly check with Unreal. So let's come down here, point our camera down there. Yep, so let's try this out again. Okay, so we have a black screen for some reason. We can see just this going on. And I think it might be because if I come back to our Visual Studio here, this one, the property is actually not meant to be F linear color. I think the range here is quite messing with things up, right? It's messing things up. So let's actually try. I think the range of F linear color is actually between 0 and 1. So we have the black color throughout our background. We could actually try and put F color and F color again, and then try building it. We might actually solve the problem, not sure. So let's come back here, and now let's reinitialize our variables, or again, I'll go for a light blue with alpha 1, obviously. And then our second background color is going to be a darker blue with, again, alpha values to be 100. Now let's try this out. Might work. And it's working, but not sure where the problem is coming from. So definitely we're getting the absorption of light, our sky color, into our material, but I think we are messing with the lerp value somewhere. So R1, B1, B1B, RGB, that's fine. Ray direction. I think we're not, yeah. I think this could be the problem. Get safe normal. Let's try to build this again. And multiply by 1, that's fine. Let's try running this again. And yeah, so now we have that beautiful sky gradient. So as I said, if you don't normalize your directions, it could actually have a very big impact on your program or your ray tracer, and you wouldn't actually notice it, right? Because ray direction, it's a more of a logical error. If you don't normalize it, it feels fine, right, not to normalize something. And if you don't clamp it to that value, you'll get errors like this, like massive errors. And you might think it's something to do with some value initialization or your values are all wrong, but it's actually pretty simple. Just get the safe normal or dot normalize, and all your errors are gone away. So let's actually position our camera somewhere down here and see our different values for our. So let's actually give a brighter color and then try our background. Yeah, so it works, right? We have this absorption of our skylight, which is a gradient. We can actually see the gradient in the metal ball as well, so that's pretty cool. And I just realized this guy's a little bit into the ground. Snap him. Yeah, maybe like that. Yeah, so we have that beautiful blue color. Now the next thing we want to do is obviously add colors to our materials, right? And we can actually do it the same way we did our sky color. We can come to our ray tracing project and then come to our hittable object actually, and then sample some F color values. So let's come all the way to our public tag, bring our U property, and then U property F color again, F color, material color, color. and we'll actually initialize or default it at just 0, right? Let's actually not do anything to it, and let's come back to our hitable.cpp, and in the scatter function now we're going to accept an f vector, right? So f vector, and we're going to call it color, and let's come back to our hitable.cpp or h and f vector color. Yeah, that should be fine. Now what we can do is, before we return our scatter direction, we can actually say the color you give in is actually going to be our material color. So material color, and we can do that for the metal material as well, or probably not, because we're doing f vector. We need to actually do an f vector statement, right? We have to convert everything to an f vector. So red, and then goes material color dot g, and then goes material color dot p. And we can do the same thing for our metal material, or probably not. We don't have to do it for every condition check, because we'll only call the scatter function once. So let's bring that all the way to the top and put it here. So for every return statement, it's the same color value, right? So that's pretty much it. And with that done, we can actually come to our scatter call, which is in the ray tracer.cpp, and let's assign a color value, right? Now where can I assign this? Because I think this is a good position. We can just say f vector material, or attenuation, right? I'm just going to say attenuation, and I'll give the attenuation here, and that should pretty much do it. So now instead of using the 0.8 value and multiplying it by the return color of the sky color, we can actually just multiply it by the attenuation, so the absorption, right? So attenuation into ray color, that should pretty much be it. So let's build this and run, and let's actually assign a couple of values for the material color as well. So once the build is done, I'll make sure I'm recording. Am I? Yeah, I'm recording. So for the monkey, we'll actually add hittable color. So we have a material color in the editor. So let's click on that and maybe give it a nice orangish color, and obviously make the alpha value 1. And for the ball, we'll give it a nice greenish tint, and then alpha value of 1. So now it should work. We should have colors for our materials, hopefully, and we don't. So everything is quite messed up. I think, yeah, maybe this one as well. We'll just give it a color, a random color, and okay, so we have this mess. We have quite a lot of blue color, and I have no idea what's causing this actually. Let's check if the background color is working. Yeah, so the background color is doing fine. It's just the materials here. So let's come back to our ray tracer and figure this out. I think for the scatter function, we'll actually use the f linear color, because the ranges are smaller, so we can multiply the ranges, right? So let's actually try that out. Let's come back to attenuation, and instead of putting attenuation in, we'll actually call a different method. This is actually going to be f linear color, right? F linear color attenuation, we'll leave that be, and we'll give f attenuation here, and then let's come down and say f vector color, which is going to be attenuation dot r, attenuation dot g, and attenuation dot p. With that said, let's add color, and we are obviously multiplying now. We don't need to do 0.5, and let's go and fix the hittable attenuation. So here everything's obviously going to be, I forgot to put this, and this is going to be f linear color, right? And let's come back to our hittable CPP. And this is going to be f linear color. So yeah, that should be pretty much it. F linear color, and the material color is actually again going to be f linear color. So we don't have to do any of this actually, just get the material color. So material color, and the material color is actually going to be f linear color. Let's see if it works. I'm not 100% accurate. I might have to check with the older files. So we have a build complete, and let's try to put some color here, right? So let's put red here, or pink, whatever. And this guy is going to be green, and the flow is actually going to be yellow with alpha, or orange, I guess. So let's render this and check. Hopefully we don't crash. Okay, so we have a lot of problems. Let's try, let's just put this as f color, I guess. Make this that. Let's try to run this. Okay, well, it was a silly error. I think you guys have caught on. You might have caught on actually. So if I come back to the project itself, this was the problem, like the order of execution essentially. So we define the attenuation. So we define the attenuation here, f linear color, and then we pass it on. But this statement was actually before we get a return statement. So f linear color attenuation RGB, that's fine, right? But we don't actually have a value before we call the scatter direction. So we just have to take this and plop it here, and we should have a visual on the screen. So let's build it again for the last time. And let's come back to this one, and let's run it. Yeah, now we have color. So we have a golden ball, golden metallic ball, and then a red monkey. The resolution is quite low. Let's actually bring up the gamma value again. Let's put 3 there, and yeah, let's come here closer a little bit. Yeah, so we see the diffuse working, and yeah, so we can see the monkey in the metallic ball as well as a reflection, right? So it's working pretty good. I can actually change the monkey to be a metal as well. So turn that on. And now we can see the monkey being a highly reflective metal head, right? So one more thing you might ask is, okay, now we have metallic materials, how about rough metallic materials? So if you're from Blender, there's an option, there are actually two options. One is smoothness, and then there is metallic. So smoothness can actually be 0 while the metallic is being 100%, right? So you'll have this unpolished metallic look. We can actually do that pretty easily in our setup here. Let's pretty much just go to our YouTube ray tracing, and then in our hittable object, actually, let's define a couple of values here, or just one value for now. We'll define fuzz and all that stuff later on, or frost, right, in the next episode when we're doing glass refractions. So let's come to our U property and give a float value and call it fuzziness, or fuzz pretty much, which is going to be at default 1. So fuzz is pretty much a multiplier to a random unit vector. So if I come back to our hittable.cpp, and when we call our metal functions, when we call our ray utilities.reflect, what I can actually do is I can just add it to fuzz multiplied by ray utilities random unit vector, right? So it's pretty self-explanatory, right? You have a point and you just multiply it to a random point by a certain weight. So that weight is actually a fuzz value. So usually the reflection goes like this and outwards, like predictable angles, with our reflection calculation or formula. But now we'll just add a slight offset to that original reflection with our fuzz value and our random unit vector. So now what we can do is build it again. So let's come back to our objects here. And actually first let's try to make our monkey a little bit fuzzy or rough metallic. I'm actually going to put the value at 0.5 and render it out. So yeah, there you go. Now we have a much more rough metallic surface. Let's come in a little closer. Yeah, so we have that rough copper kind of look. So this could be a copper monkey for all I care. And that we can also see that ball become a little bit more rough because of the random unit vector. If I go to the ball again, and if I bring down the fuzz all the way to 0 and render it again, now we'll have a much smoother metallic appearance. Yeah, so we have a very smooth metal ball, or very smooth metal ball, and a very rough metallic monkey. Yeah, so there you go. So that's pretty much it for today's episode. If you guys found the video informative or entertaining, make sure to leave a like and do subscribe. It really does help me stay motivated to create more videos for the series. With that said, I will see you in the next episode.